Hi, this video will demonstrate how to solve a linear equation. Alright, and we'll go through a couple of examples. But first I just want to review how we solve things. Alright, remember our goal is to isolate our variable on one side. Alright, so we want to isolate our variable one side. Alright, and then figure out what our solution is. And that's our goal in the linear case. It won't be our case, the goal in the quadratic. But in the linear case, we want to isolate our variable. And then we want to use our rules of multiplication, the multiplication and addition principle, okay, to do that, right? And then we come up with our solution. And what I want mainly you to remember is that a solution is a value that makes our equation a true mathematical statement. Okay, and this is important because we're going to solve things all semester. All right, when we solve things, we come up with a solution. And from now on, when I say solution, what you're looking for is the value of our variable. 9 times out of 10, it's going to be x, all right, that makes it a true mathematical statement. And what that means is when we come up with that value for x, we can plug it back in and it makes a true statement. All right. So with that background out of the way, we're going to actually do 2 examples. All right, these are from the book, so if they look familiar, you've probably been working examples from the book. But the first one is 2 parentheses 1 minus 3x, close parentheses, plus 1 is equal to 3x. All right. And what we want to do in this case is first get rid of this parentheses. And remember, the way that we get rid of parentheses is by distributing whatever is out front. And when we distribute, we have to multiply every single term in our parentheses by what's out front. In this case, I've got to multiply 2 times 1, and I've got to multiply 2 times minus 3x. Most students get the first one. And from time to time, they tend to leave out the second one. So what happens to get rid of these parentheses is I'm going to have 2 times 1 gives me 2. 2 times a minus 3x gives me a minus 6x. And now the plus 1 had nothing to do with this parentheses, so it's just coming along and then equals 3x. And now remember, when we're solving a linear equation, we want to get all our variables on one side, all our numbers on the other. All right, so my next step here is I can combine a 2 and a 1. I get 3, and now I've got minus 6x equals 3x. And I want to get all my variables on one side, all my numbers on the other, so I'm going to add 6x to both sides. This would be the addition principle, which states I can add and subtract anything I want on either side of the equal sign as long as whatever I do to one side, I have to do to the other. Okay, so I can't just add 6x here and not do it over here. So over here I'm left with a 3. Why? Because 6x plus 6x gives me 0. Plus 3 is 3. And over here I'm left with 3x plus 6x equals 9x. And now for my last step to isolate x, I'm going to divide both sides by 9. All right, and this is actually my multiplication principle, even though I'm doing division, but it's the multiplication principle. Over here my 9's cancel. Over here I can reduce this. 3 goes into 3 one time. 3 goes into 9, 3. So I get that x equals 1/3. So that would be my solution. And now, what I was saying before, when I plug this back in, should make this a true mathematical statement if I plug this in for x. Okay? All right, so all I'm doing is taking my answer and plugging it back into the original formula wherever I had an x. So this becomes 2, 1 minus, well, 3 times 1/3 just gives me a 1. All right, plus 1 equals 3 times 1/3. All right, so this actually goes to 0. 0 times 2 gives me 0 plus 1, and over here I'm left with 3 and a 3 cancel, and I'm just left with 1. So 1 equals 1. That is a true mathematical statement, so that is my solution.